This is Unit 1 of the Honors Math 2 final review. We're starting off on 61. So 61, we are going to combine like terms. I have two x squared terms. I have 5x squared and 2x squared gives me 7x squared. I have a 3x and it has no other friends, so that's just a 3x. And then negative 7 and negative 8 give us a negative 15. For 62, it's the same idea, but now it's subtraction. We need to make sure we change the signs here on both of those. So it's now a negative 2x squared and a positive 8. I have 5x squared minus 2x squared is 3x squared. 3x again is by itself, so plus 3x. Negative 7, positive 8 is positive 1. For 63, I'm going to distribute in 5x squared y. I get 35x to the 5th y. Remember, add exponents when you're multiplying. The next term would be negative 20x to the 3rd y squared. And then the last one is just minus 5x squared y. For 64, I'm going to distribute in, and then I'm going to combine like terms. So I'm going to first do that with the 3c as well as the c. We get 12c to the 3rd minus 15c. And a negative 9c squared. I don't have any like terms though, so I'm just going to write this in descending order, 12c to the 3rd minus 15c minus, try it again, 12c to the 3rd minus 9c squared minus 15c. For 65, we need to multiply binomials. I commonly tell my students to make a box and multiply, but some want to do FOIL. Whatever method, just make sure you are multiplying correctly through the terms. We got 6x squared, a 10x, negative 21x, and negative 35. So I got 6x squared here. 10x and negative 21x is negative 11x combined minus 35. For 66, I'm going to draw a box again. This time it's going to be a 2 by 3 with 2x minus 5, 3x squared, x, and minus 4. So my box has become 6x cubed, 2x squared, minus 8x, minus 15x squared, minus 5x, and 20. Make sure we combine like terms. I have 6x to the 3rd. Here I have 2x squared, and minus 15x squared gives me a negative 13x squared. Negative 5x, negative 8x is a negative 13x, and then plus 20. For 67, do not make it 9x squared plus 121. Don't just distribute in that exponent. It's addition on the inside. We need to remember this as 3x plus 11, 3x plus 11, and multiply like we would in the previous two problems with the box. If you just go in and square things, you forget terms. It is not mathematically correct, so don't do it. We get 9x squared, 33x, 33x, and 121. When we combine those terms, yes, we do have the 9x squared and the 121, but there's also a 66x there. You gotta remember that term. 68, I'm gonna multiply 5y minus 1 by itself first. Then, hopefully not, I don't forget the 2 out in front. So we get 25y squared minus 5y minus 5y and 1. So 2 out in front, didn't forget it, that's good. 25y squared minus 10y from the 2 negative 5y's plus 1. Distribute that in, 50y squared minus 20y plus 2. And why that problem is probably written that way is it's going to see if you distribute in the 2 first or you multiply. You need to multiply the 5y minus 1 times itself, then multiply in the 2. For number 69, if we go in and multiply, we have x squared plus 3 and x squared minus 3. So same idea, now we just have a little bit higher powers. X squared times x squared is x to the 4th. 3x squared, negative 3x squared, and negative 9. These are terms become 0, 3x squared and negative 3x squared. So I'm left with x to the 4th minus 9. This is a good example of difference of two squares when we factor, which will be from problem 72 on. But so we do have to multiply together. Now if you recognize the pattern, you may jump to that, but we always do have that backup of Multiply, use the box, use FOIL, get to the solution. Now, last one for 70. We're not multiplying here, we're combining like terms. I have 4x squared and 9x squared, gives me 13x squared. I have a negative 5x, a negative 2x, and a negative 11x. Now I'm just make that plus, throw a negative, and change that sign as well. So negative 5, negative 2, and negative 11 is negative 18x. Last one, we have 6 and positive 3, so plus 9. Now 71 can sometimes confuse students, but what we're going to do is treat this as like a problem that started like this. Multiply these two, then whatever result we get from that, we multiply that one onto it. So it's almost like starting with a problem like this, with two of them. You multiply, it's then going to look like this, and you multiply out. It really doesn't matter either which two you pick. I'm just going to pick the first two, because they're the first two. So I got 3x squared, x, 18x, and 6. So 3x squared, this is 19x, plus 6. I'm going to throw an x minus 2 onto that. So now, we get 3x to the third, 19x squared, 6x, negative 6x squared. 19 times 2 is a negative 38x, and a negative 12. Careful combining like terms. I have 3x cubed. I have a 19x squared and a negative 6x squared, so that'd be positive 13x squared. Positive 6x and a negative 38x is negative 32x, and then minus 12 at the end. So we've gone in, we've multiplied, we've put things together. Now what this section starts, or this unit starts to do, is factor it. So we go in the reverse direction. We always look for greatest common factor to start off with. So if I look at number 72, I can factor out a 5x because it's something they all have in common. Taking a 5x out of the first term makes it an x squared. Out of the second term leaves me with a 5x, and out of the last term it's minus 9. Now, we'll get to the factoring in a minute about breaking that apart, but this one is just factor out a greatest common factor. You should be doing that first. We go to problem like 73. It does not have a greatest common factor, but this is where we're going to factor it into binomials. And what we're going to look at is we need to multiply to this value and add to that one. So finding two numbers that do so. If I'm multiplying to 10 to add to 5, 2 and 5 come to mind. So I'm going to break this to make it x plus 2, x plus 5. And those are the factors. If I did that in the reverse order and put this together, it would come back to be x squared plus 7x plus 10. Next one, 74. I need to multiply to 15 to add to 2. Well, the fact that it's negative 15 means I need one of them to be positive or negative. So like if I did 5 and 3 and picked which one to be negative, and I know they have to add to be 2, these are 2 apart, but I want to make the 5 positive and the 3 negative so that when I add them I get a positive 2. If I did the opposite of that and made this negative and this positive, they would add to be a negative 2, and it doesn't work. So I'm going to make this into x plus 5, x minus 3. For 75, I need to get a negative 36 from multiplying. That adds to 9. 36 is 6 and 6, but if it's a negative, 1 negative, 1 positive. That's not working. I could go 12 and 3. 12 and 3 are 9 apart, so which one do I make negative? I'm going to make the 3 negative. Adds to 9, multiplies the negative 36, so go n plus 12, n minus 3. For 76, we got to multiply to negative 21, add to 4. 21, 7, and 3 come to mind. One of them has to be negative, and I want the bigger one to be negative, because that would make the sum negative. So if I go negative 7, those do combine to be negative 4, so we go y minus 7, y plus 3. Now 77 all of a sudden adds some more variables in. All this problem means is it's now going to be a something b, a something b, and it's going to follow the same process as before. How can I get to 32 that adds to 12? Well, 32 is 8 and 4. So 8 times 4 is 32. 8 plus 4 is 12. So that's going to become a plus 8b, a plus 4b as my two factors. Now, if you're ever not sure about the way you factored it, you can always check it by multiplying it back together and seeing it goes back to the original result. They're just kind of the opposite order, opposite operation of one another. You can factor, you can multiply, you can check your answers. All right, now we're on number 78. The first thing I notice here is I can factor out a 2. Factoring that out makes things nicer for us. I'm looking now to get to multiply to 75, not 75, 45. That adds to negative 18. 45, if I want positive but a negative sum, they both got to be negative. 45 is negative 9, negative 5 is 14. That doesn't work. We could do negative 3, negative 15 is negative 18. So we're going to go 2, g minus 3, g minus 15. Now, 79 kind of starts out looking like 78, but there's no greatest common factor. So this is where we kind of change the way we factor it, where we have a coefficient out in front. I'm still going to use the fact I multiply and find that sum to add, but I'm going to use factor by grouping to help me out. So now I'm multiplying the first term, last term, and I get negative 30. It's got to multiply to negative 30 and add to 7. Well, 30, I get 10 and 3 coming to mind. And I'm going to want the 10 to be positive and the 3 to be negative. And what I'm going to do here is I'm going to break that 7x into two terms. I'm going to make it a 10x and a negative 3x. I'm not changing the statement at all. I'm just changing the way I look at 7x. So now that it's this way, I have 4 terms and I can do factor by grouping. I'm going to take out a 2x from the first two terms and I have 3x plus 5. I'm going to take out a negative 1 from the next two terms and get 3x plus 5. I want these to match. These have to match for this process to work. If they don't, you either made a mistake or they don't factor. But now that they match, I take that out of both. And now that they're gone, I'm left with 2x minus 1. So 3x plus 5, 2x minus 1 are my factors, and it's done. If you need to, multiply them back together, and it will come back to this original result. It's a nice way to check if you're not sure. Now for 80, I'm looking at it. 5 times 2 is 10, so multiply to 10, add to 11. Well, that's 10 and 1. So we're going to go 5y squared plus 10y plus y plus 2. I can take a 5y out of the first two terms. Leaves me with y plus 2. I don't need to take anything out of the second two terms, but I'm going to say it's a 1 because when I take it now, the y plus 2, which is in common, I'm left with 5y plus 1. For 81, I'm going to factor out a 3 first. Leaves me with 4x squared minus 8x plus 3. And then we multiply. I'm going to multiply to 12. That's 4 times 3. That adds to negative 8. So we go negative 6, negative 2, because if it's multiplying to be a positive but adding to be a negative, they both need to be negative. So the 3 is going to just tag along here. I have 4x squared minus 6x minus 2x plus 3. Factor the first two, I got a 2x coming out, 2x minus 3. Negative 1 coming out, 2x minus 3. So my final answer is going to be the 3, 2x minus 3, and then what's left being the 2x minus 1. Now for number 82. Now this one is a little bit different. It's one of the patterns we have. It's one of the shortcuts. I'm looking to multiply to 49. That adds to negative 14. Negative 7 and negative 7 work for that. So we're going to go x minus 7. X minus 7, but you need to expect that they will write this as x minus 7 squared. For number 83, I'm going to factor out a 5a first. I'm left with a squared plus 6a plus 9. Here, what do I multiply by 9 to add to 6? It would be 3 and 3. So it's going to be 5a, a plus 3, a plus 3, or they would write that as 5a and then a plus 3 squared. Number 84 only has two terms, but it has a square there. That is a difference of two squares. If these two are squares, it's going to be the square root of them, which is 3x and 5. But we said difference of two, so it's going to be a minus and a plus when you do those two. It splits out to that. They are not the same. If they were the same, they would have had three terms, like numbers 82 or 83. It's when it's a square minus a square, it becomes these two. It's just a pattern we need to recognize, we need to find as we go through. For 85, we have four terms. Four terms, I want to think factor by grouping. I can take out a 3x squared from my first two terms. I'm left with x minus 4. I can take out a 2 from the next two. I'm left with x minus 4. X minus 4 is in both. Leaves me with 3x squared plus 2. I look, it doesn't factor anymore. It's not a difference of two squares. We're done. 86, I can take out a 3y squared. I'm left with 2y plus 1. I can take out a negative 5. I'm left with 2y plus 1. So we got 3y squared minus 5 and 2y plus 1 as my two factors. 87 is a little bit tricky. It involves looking at the ways we can factor. And I want to look at this one first and change the names of things. Let's think of x plus 7 as a and x minus 2 as b. And if I did that, I have a squared minus ba. And looking at that in terms of factoring, they both have an a in them. So if I took the a out, it would be a times a minus b. Now when I put that back in, what I originally took out, it's now x plus 7 minus x minus 2, which is this solution. So it's a little bit different ways to factor. We need to be careful moving things around, but it's using that idea of you can factor whole terms before you multiply them out. Okay, last set here, number 88, I'm going to multiply this whole thing together and fill in the blanks, but we can kind of do a little bit of a shortcut here because I know that the lead term in this is going to be the 2, the 4, and the 3 multiplied together. Think of it if we did box method, 4x plus 3 and 3x plus 5. The 4x and 3x are going to give us 12x squared times 2 is going to be 24x squared. Same thing is going to apply for the last term. The last term is going to be the 3 and the 5, and then we throw in the 2, which is also multiplied. So that's 3 times 5 times 2 is 30. So 24x squared plus 58x plus 30 is my solution. I don't need the 58x, they already gave me that, but we could go through and check. If you went through, did 4x plus 3 times 3x plus 5, we got 12x squared plus 9x plus 20x plus 15. We'll combine like terms. And now I'm going to distribute in the 2. And I get 24x squared plus 58x plus 30, which matches what we had.